Ladies and gentlemen, I want to welcome you to the Valley of the Shadows of Essential Mathematics and Statistics for Data Science. Today, I want to just look at descriptive statistics, basic descriptive statistics. It's going to help you. Remember, this quote is very useful. Until what you know helps you and someone else, what you know is useless, because the evidence of knowledge is result. You can't tell me that you have the knowledge and there's no result, because the essence of knowledge is application of knowledge. And once you apply knowledge, that is called wisdom. Wisdom is the ability to see what is obvious, even when it is a secret. You got to use the knowledge you have to benefit you. Then you can benefit someone else. All the course outline, I posted it in the group page. If you want it again, you can let me know on the page. Please ask as many questions as you can on the group page. Ask many questions. Ask many questions. A questioner is never lost. So let me start by telling you what is mathematical statistics in basic fundamental terms. Okay. Statistics itself was defined by David Hahn. David Hahn was a former past president of the Royal Statistical Society in the UK. He said, statistics is both the science of uncertainty and the technology of getting information from data. Data is oil today. Artificial intelligence is the new electricity in the world. Statistics helps you to collect those data, organize them, analyze them, interpret them, and boom, present them to the world. With that data, you can make a lot of inferences in the future. Most of the things that happen in the world, you can use statistical analysis to be able to fully understand them. Today, I just want to look at an aspect of statistics known as descriptive. It's the easiest statistics you can look at. Because with descriptive statistics, you can use tables, you can use visualizations, you can use some small quantitative analysis, and then you can come out with useful, important things. Okay. Now, let's look at the benefits of statistics, basic benefits. You can use it in the stock market. You can use it in the weather. You see the way the meteorologist, the weatherman predicts the future. You can use the statistics to be able to do that. You can use it in insurance. The probability of a person defaulting, if that person should get a bank loan, you can use it for all of that. So it's practical. But there are some elements of statistics you got to know. Basic elements. The population, the sample, the variable, and the parameter. So let me just ask you, okay? Let me just do some quick asking. What I have here is A. What I have here is B. Which one is a population? Which one is a sample? You can tell me. Which one is a population? Which one is a sample?
A is the population and B is
oh, please always raise your hand. It's a very, very respectful way of communication. Otherwise, at a point when you all have the answer, everything will be loaded up. Zoe.
Thank you, Prof. And my apologies for speaking without being granted permission. So I'll say that A is the population and B is the subset.
So what then is the difference? Another question to everybody. What then is the difference between the population and the sample? What's the difference between the population and the sample? Anytime you're asked to indicate a difference, don't define this and define that. Any?
Okay, so the sample is a subset of the population.
Super. Write it down. That's an excellent answer. A sample is part of the population. So in that case, why don't we take the population but we want a sample? Why don't you take the population but you want a sample? You should go for the population. People don't go for the population. Why? Why don't you take the population and be free? Because, any is your hand still up?
Sorry, let me drop it.
Right.
Hello, sir.
Go ahead.
All right, so with the sample, it can help you make inferences in the population. So you can pick a sample size that can make you draw conclusions from the population that you are trying to study.
Yeah, but my
So-
question is, why don't you take the population?
Because the population is bulky. So
What do
analyzing
you
the
mean by it's
population.
bulky? I want to understand that part. Don't you like bulky things?
Yes, but then it makes it quite difficult.
Why
If
is it
you-
difficult? You need help. Don't worry. Somebody will help you. Eric, what do you say? What do you say, Eric? Philip.
So factors such as time, funds may not allow us to use the entire population.
Okay. Well, the fact is that the population is unknown. In most cases, you cannot get the entire population. It's not known. Okay. And because that is not known, you take a sample to mimic the population, to represent the population. And we shall be looking at part of that. Let's take something. A typical example of a population is all the items of interest of a particular decision. If you look at all married drivers over 25 years old, that is a population. All married drivers over 25 years old. But all subscribers to Netflix is another population. All subscribers to Netflix. The sample would be those subscribers to Netflix who subscribed only comedy. Those who rented only comedy movies. So now, those who rented only comedy movies will be the sample, the subset of those subscribers to Netflix. That's a typical example. You need to know examples of anything. Always remember that example is more efficacious than precept. So why do we sample? Because we want to get enough information to draw valid inferences about a population, which is unknown. Don't forget that. It is not, because even if you get some of the population in UK, you will not get some of the population in Ghana. You know, sometimes the population is so big that you can't even know the rest. Because a person in Ghana will be behaving by virtue of what he knows or has seen in the UK. And so the behavior here is influenced by a behavior somewhere else. And you need that somewhere else information to be able to make the conclusion. But you don't have that. You don't have that. That is why you've got to get a sample. There are some kind of types of data that you will learn. Okay? You will not learn all of them with me. You will learn some of them along the line, quantitative and qualitative. Quantitative is numerical, qualitative is categorical. Quantitative, you collect and interpret data with numbers and graphs. Qualitative, you are using text, you are using sound, you are using pictures, you are using media. Social media is a typical example of a qualitative, but the analytics of social media is quantitative. So let's try to understand some key notations in statistics so that you will appreciate it more. There are a lot of Greek letters you see in statistics. Many Greek letters. Okay. Sometimes you have variables that are subscripted, like you have a superscript and then you have the subscript. The subscripts are the ones that are below, the superscripts are the ones that are above. Okay. And you tend to use some of these things. For example, there are some Greek letters that we use, such as mu. Mu is used to represent usually the average, particularly the mean. We'll come to that. Then sigma is to usually represent the variance. Then the square root of this variance, we'll look at it. Then sometimes you have pi. All of these are used to represent something about a population. You're just representing something about the population. And then sometimes we talk about the sample size, the population sample, the population as well as the sample, the size of the population as well as the size of the sample. We use the Greek sigma a lot, this symbol, we use it. What does that symbol mean? You can tell me, what does this symbol mean? Selassie.
So it means summation.
Okay, ladies and gentlemen, let me tell you something. Even if you know anything, always have a book and be writing everything. The human mind, the human brain does not like to think. That is why it thinks. 90% of what I will teach you, you'll forget them. The only way you remember them is when you have documented the process. Always remember, write, because there's an information symmetry between your fingers and your brain. Each time you write, you tend to understand it better and you tend to refer to it better. Okay, now let's move on. Let's move on. We've got some interesting things to look at today. Today, I will not take much of the time at all, okay? But we'll do a test. Yeah, we'll do a test. Okay? So there are two kinds of statistics, descriptive and inferential. Descriptive and inferential. We shall do descriptive today. Inferential looks at the future, what should happen or what will happen. Okay? And the descriptive is looking more at what has happened. What has happened or what is happening. Okay? We'll look at descriptive today. So the first thing you're going to do under the descriptive statistics is to look at the measures of central tendency, what you might call the center of something. I want you to look at this data set. Okay, you have this data set. It's a data set made up of staff, and these staff are generating some sales. Okay, and this is one particular staff. This is a number and what the staff is generating. There's another staff, and that's what is generating. There's another one, that's what is generating. Then there's another staff, that's what is generating. Okay, so you have this information there. Now, on the basis of this, you can see that if I put one on the far end here, if I try to draw a circle, where is that? If I try to draw a kind of the edges here, okay, the edges here, you will notice that there is a particular number that appears to be in the center. I didn't label them, but you will notice that the center is likely to be this number. Do you all agree with that? Yeah, that's the sort of the center. That center, yes, Christy. Oh, you're going to give me an answer, eh?
No, sir, it was a mistake, sorry.
Okay. So that's it. That's the center, man. Now, we always want to know the center. Why? Because the center will tell us that you are not bad after all. You are among everyone. The center. The center. One of the major things in statistics, in all angles, is trying to find the center. Because the center will represent everybody. It will represent everyone. And that is why we always try to understand the measures of central tendency. There are three major measures of central tendency. Who can give me one? There are three major measures of central tendency. Who can give me one? Right. Right. Rosemary.
Mean.
Mean. Eric.
The mood.
Mode. Clifford.
The median.
The median. These are the three major measures of central tendency. The popular one is the mean. So please remember the word average is actually not just the mean. It's a mean median mode, but the mean is only the popular one. Now, when it comes to the mean, there are three major, of course there are four, but then there are three major means. And people don't normally talk about all of them. They only mostly talk about the first one, which is the arithmetic mean. The arithmetic mean. Ladies and gentlemen, we are going to learn about each one of these means. And after that, I'm going to give you something to work out. It is the way you take what I'm about to learn now that will help you to be able to get the sort of test we do. In explaining each one of these, I'm going to take this few numbers. Let's take something like 1, 3, 7, and then let me come somewhere 2, and then 5. Let me see. Let me do another one here. Okay. All right. So I'm sure you guys can see. Write them down. And let's try to explain the first mean is arithmetic mean. The arithmetic mean, you all know this already. You all know this already. Who can quickly tell me the arithmetic mean of these numbers? Who can tell me the arithmetic mean of these numbers? Yes, any?
4.
Good. Okay. That's 4. Okay. How did he get a 4? He added each one of them and divided it by the sample size, which is what? 6. And when you add each one, 1 plus 3 is 4, 4 plus 7 is 11, plus 2 is 13, plus 2 is 15, plus 5 is 20. 20 divided by 5, is it divided by 5? Did it say 4? Yes, Priscilla.
Where's this one?
I think it's 0.3.
Yes. But none of you was talking, eh? All right, so what did you get?
3.3.
Okay, let me make the number a little bit different so that it'll be easier. That is, let me delete one of them. Okay, let me delete this and make it 4 now. So what does it mean now? What does arithmetic mean?
Now is the 4. My
Good.
4.
All right. I decided to just make it like that so that it becomes like that. Okay. So now the mean is 4. That mean is called arithmetic mean. For those of you who don't know, you just add everything divided by the size, which in this case is 5. That is how you define the mean. But the mean has an issue. One of the issues of the mean is that it can be affected by outliers. Who can tell me what an outlier is? What is an outlier? An outlier is an observation. Oh, yeah, right.
Okay, so I think they are extreme values.
Good. It's an extreme value. Okay. An outlier is an extreme value, but an outlier is different from an influential observation. Find out. An outlier is not the same as influential observation. An outlier is removed, okay, but you can be removed by an influencing. Okay. I can give you an example. Suppose I have this information here, and you have this one here, this one here, this one here, this one here, this one here. Then all of a sudden you have this one there. Okay. So if you look at this guy who is on the far end here, this guy, he is an outlier, but he is not influencing the data set significantly. But suppose you move that guy out, okay, and you rather bring this guy here. Okay. Whereas it looks like this thing is going that way, because of this guy, the line might go this way. So he is not just an outlier, but he's an influential outlier. Hope you get it. An outlier is one that is removed from the rest of the data. And mean can suffer from that because these very numbers, there are 5 observations. But if I should delete the 5 alone, okay, and I make the 5 50, if I make the 5 50 and you should calculate the mean, you are going to get 65 divided by 5. That's what you're going to have. Okay, what would that be? 65 divided by 5. Is that it? 65 divided by 5, that will give you 13. Right. It's 13, right?
Yes.
Good.
Yes, Paul.
So it is 13. Do you know what that means? Meanwhile, majority, so if this guy is 50, this guy alone has driven the mean upward. You realize that? He is an outlier and an influencer as well. Okay? And that 13 is bigger than 4 of the numbers. So his influence is affecting. He's making the mean look like 13 when in reality, majority of them are below the mean. So mean can suffer from that. Median cannot suffer from that. And you're going to see that very soon. Median will not be affected by outliers. So that is how you calculate arithmetic mean. Another mean, which is very useful, especially for rank data, take note, for data that is ratings, rating data, ratings, ranking, ordinal, ordering, okay, is geometric mean. The way you calculate the geo mean is not the same as the way you calculate the mean, the arithmetic mean. How do you calculate the geo mean? Guys, watch this because you're going to do yours. Okay? This is how you calculate the geo mean. You take the 1 multiplied by the 3, multiplied by the 4, multiplied by the 5, multiplied by the 7. Okay? Then you multiply all of them. Then you take the fifth root of them because there are 5 of the sample size. So you take the fifth root of that. Now, if you don't want to take the fifth root, another way you can say this is that you now take the to the power 1 over 5, where the 5 here is a sample size. And then you calculate that. That will become the geo mean of these numbers. Calculate that and let's see. So you said the mean was 4. What is the geo mean now? If the mean is 4, what is the geo mean? Right, your hand is up. Someone says, are outliers extraneous variables? No, they are not extraneous variables. Outliers have to do with numbers, not variables. They are numbers, not variables. Yes, Priscilla.
So it will be 3.35.
Again?
3.35.
Okay, so that will be 3.35. Okay, so and usually the geo mean is below the mean, and you're going to learn that the harmonic mean is even way below. Okay, so watch it. Oh, I want somebody else to confirm. Who's going to confirm for us? 1 times 3 times 4 times 5 times 7. That will be 420. Can somebody confirm what Priscilla got? Joseph, can you confirm?
Yes, I confirm.
Good. So that's 3.35. Okay. So that is how you calculate the geo mean. You're going to do a test right now, so know how to calculate it. If you are stuck, let me know. If you are stuck, let me know. Now, the next is a harmonic mean. The harmonic mean, the geo mean, like I said, the geo mean is quite cool. Stock market analysis, dividend analysis, interest rate analysis. You use that. Now, the harmonic mean. The harmonic mean calculation can be quite tough. But once you know the geo mean and the arithmetic mean, you can calculate the harmonic mean. Because the harmonic mean is given by the square of the geo mean. That is 3.35 squared divided by the arithmetic mean. That is 4. What do you get? What do you get? Priscilla.
2.81.
All right, so that's correct. Okay. That's, oh, hold on. Fatima, can you confirm that?
Yes, please, 2.8.
Good. So remember I indicated to you that a harmonic mean is usually even lower. Okay. So these are calculated, and these are different kinds of mean that you use, okay, but for a purpose. So what I want you to do now is go and find when is it useful to use a harmonic mean. Find out. Find out before you see someone. When is it useful to use a harmonic mean? When is it useful to use a geomean? When is it useful to use a mean? The harmonic mean, sometimes we say harming. Harming. It sounds like somebody who's young. Harming. Okay. So these are the different kinds of means that you will have to know in your course of this whole journey. Okay. Any question on this? These are just measures of central tendency, by the way. No question. Fantastic. Let's move on. Now, let's go to another measure of central tendency, which is the median. Now, as you know very well, the median is done when you have arranged everything in an ascending order. This is for ungrouped data we are looking at. When you arrange everything in an ascending order, and our values were 1, what were the values? 1, 2, 3, 5, 7, right? Is that it? No. Remind me of the numbers I gave you. Kojo?
Yeah, so Proverbs 1, 3, 4, 5, 7.
Okay. So what you had to do with the median is to first arrange it in an ascending order. And then after that, you take the middle value. So hold on, I'm going to let somebody tell me the median, someone who has not spoken at all from here. So let's take someone like Irabana Bini. Are you here? Irabana Bini. Are you here?
Hello.
Yes, tell me the median.
4.
Okay, good. I think that, what's the name? Those people who have been talking a lot today, they can confirm. I think Priscilla has been quite Christine in talking. Christy, can you confirm that you look like a smart person, eh? Or you're not? So that's 4. Okay, that's for the median. So you get a value of 4 for the median. What is the mode? The mode is the value most recurrent in the sample set. Now, if you look at this thing, what would you say is the mode? What do you think is the mode? Let me see whether you guys are great. Valentina.
But like, there's no mode.
That's it. That's it. Okay. So you shouldn't be shy to have said that. Okay. You were a little bit, no, you were right. Okay. So it's not all the time. It's not, remember, the number 0 is also a number. It is the most important nothing of all something. 0 is the most important nothing of all something. If you don't understand that, you can ask me. All right, let's go to another. So those are the 3 measures of central tendency. And you can use any of these things to measure the center of any data set or any information. But the fact that you have the center doesn't mean that others are not deviating from the center. And so there are measures of spread, measures of dispersion. That is how far, remember the mean here was 4. Okay. The mean was 4. So the question is how far is any of these from the mean? Alpha. Dispersion will measure, or we call deviation, will tell you the degree of variability in the data. The spread, how scattered or nucleated the data is. That is the measures of dispersion or spread. There are about 5 of them. The first one is a range. The range is a very simple number. The maximum value minus the minimum value. So guys, from what we have here, can you tell me the range? Who can tell me the range? What is the answer for the range? Raise your hand. Tell me. Ruth.
Okay, Prof, it's 7 minus 1. That will give you 6.
Excellent. Remember, today's lecture is easy peasy. Okay, you should be smiling already. But as we go further, not today, as we go further in the course, you will enjoy the rest. Today is the warm-up. Now let's look at the next one, which is the interquartile range. It's also a measure of the spread or dispersion. Okay. So first you got to do is to arrange the data, subtract the third quartile, okay, from the first quartile. So first of all, we got to know what is the first quartile and what is the third quartile. The median is not part of either of them. Okay. The median is not part of the lower half and then the upper half. The lower half is the first quartile, the upper half is the third quartile. Okay. So the first quartile of the data is made up of the values less than the median. It is a median of those values. So first of all, let's look at this. The first quartile, and again, I'm not asking you to do this because you're going to do one. The first quartile is going to be, now, first of all, what's the median of these numbers? What's the median? You already know the median to be what? Sophia.
Please, the median is 4.
Good. So guys, watch this. The median is 4. Okay. Now, the first quartile is going to be the numbers before the 4. The numbers before the 4, the median of those numbers. Now, the numbers before the 4, what are they?
Please, it's 1 and 3.
1 and 3. And what is the median of that?
Please, it will be 2.
It will be 2. Very good. So you keep that then. That becomes the first quartile. Now, the third quartile is the median of the numbers after the median. What would that be?
Please, the number is 5 and 7.
And the median of what?
The median.
Crystal, help it.
The median will be 6.
Exactly. The median will be 6. So this 6 is the third quartile. This 2 is the first quartile. So what will be the interquartile range? You can tell us now. I think you guys are cracking the code. Valentina.
It is 4.
Exactly. So in this case, the interquartile range also happens to be the median. And it is also the mean in this example. That is it. Now, why are we doing this? Well, because in some situations in data, you will need some of these things to give you a better perspective of things. So that's how you calculate interquartile range. Now let's look at the variance. The variance is another measure of dispersion, another measure of spread. How far away is everyone from the center? How far? The variance is just the measure of the spread between the numbers. How do you calculate the median? The variance is very simple. Look at it. Look at it. What you got to do, first of all, is to find the mean of the numbers. In our own, what was the arithmetic mean? Do you remember the arithmetic mean?
Yes.
What was it?
It's 4.
was 4. So now you take each value minus the arithmetic mean. So it's 1 minus 4, 3. 3 minus 4, 1, negative. Okay. You take each one of them and you are going to square them. When you're squaring them, you are clearing the negatives. When you're squaring them, you are clearing the negatives. When you are done, you sum them together. And you divide them by the sample size. In this case, 5 minus 1. And that will give you the variance. That will give you the spread. Now, this variance is for each one of them, but it gives you the average of the whole spread of the data set. If I tell you to calculate that, can you calculate that?
Yes.
Good. So calculate that and let me see. Whoever is done, let me see. Let me know your answer privately in the chat. Let me see the greatest creme de la creme of this room.
Yes.
Begin to enjoy this course, even if you don't like the course. I know some of you are beginning to like it, but begin to enjoy it. Force yourself to enjoy it, and it will become enjoyable. All right. I'm seeing some of the answers that some of you have written, and it's getting interesting. It's getting interesting. And some of the private answers that I'm getting are interesting. 2.24, 5, 2.5, you know, variance. Somebody has written 5. Somebody has written that. Somebody has written 5.2. Sorry. Okay. But someone is saying that I wasn't talking. Don't worry. I was giving you time to calculate. Okay. I was giving you time to calculate everything. So it's okay. It's okay. Those of you are writing further answers. It's okay. So what do you think the answer is? It's 5, isn't it? You all agree that it's 5?
Yes, Prof.
Yeah. So that is a consensus answer. That's the variance. So it means that even though the mean, the arithmetic mean is 4, the deviation, the net deviation from this is 5. And that means that if I move away from 1 to 3, 1 to 3, 3 to 4, 4 to 5, 5 to 7, the deviation is 5. And when you technically look at it, it is 5. If you have a mathematical eye, you see that. Now, the square root of the variance is a standard deviation. So once you've calculated the variance, you can get the square root of that to be the standard deviation. The variance and the standard deviation are both measures of dispersion. But as the name sounds, the standard deviation helps you to standardize the deviation or the dispersion. You standardize because sometimes there could be different units of measurement. And so you can, the root says 5 all the way. Yes. All right, let's move on. So at this stage, I'm going to give you this to work now. You are going to do this calculation for all of us to see. Okay. In fact, it's going to be the one that I'm going to let you do. You are going to calculate. I have a data set for you here. Because the first one, it's possible that some of you are copying. Consider the following sales for Group Z for 11 months of the year 2024. These are the sales. Remember, they are not in alphabetical, they are not organized in ascending order yet. You have to calculate the arithmetic mean, the geometric mean, the harmonic mean, the median, the mode, the range, the first quartile, third quartile, interquartile range, the variance, and the standard deviation of this data set. I'm going to give you some few minutes to do this. Okay. Let's begin. So I'm looking at the answers of Clifford and Kwadwo, and it's getting interesting what these two actually did, because it appears that they were on the same wavelength. I don't know how they shared it or whatever they did. Kwadwo and Clifford, do you know each other? All right. So the first thing is to find the arithmetic mean, and it's fairly simple here. Okay. This is arithmetic mean. You're supposed to add all of them, and then you divide by the sample size of 11, and that will give you 116.82. That is what you get. 116.82. And I can see that, those that brought their answers earlier, they got it. Then you look at the geomean. Okay, that's fairly simple. That is 114.08. That was done. It's perfectly executed by Kwadwo and Clifford in particular. They got that. The harmonic mean, okay. In fact, I didn't see how they calculated it, but the harmonic mean is 111.4. Okay, 111.4. Perfectly executed. So those were the early ones. Now we go to the median. The median was a very simple 120 because it appears multiple times. Then the mode was also 120 because it appeared multiple times. The median was the middle number. The mode was the multiple appearance number. So those two were 120 each. The range, as you can see, there were 6 numbers to the left of there. So those 6 numbers to the left of the median, you get the mean of that, you get 75. Okay, you can see 75. Then the one above, you get 160. That's the highest value. And then the lowest value, and that will give you 85. And I can see that these guys got that as well. The quarter, the first quarter was 95. It was the median of the median. The second quarter, 135, the median of the median. Then you have the interquarter range to be 135 minus 95, and that was a value of 40. That was a value of 40. So now you have the interquarter range to be 40. That leaves us with the next thing, which is the variance. When you calculate the variance carefully, you're going to realize, of course, the problem with the variance is that the mean, you got to use the mean, which is quite loaded. But you will get this number of 656. And I can see that Clifford and Kojo actually cracked that one as well. And then you have the standard deviation, which is the square root, which is 25.62. Again, that was perfectly executed. So Yvette Sonia also seems to have actually cracked these things one by one. So basically, when you take a time and you look at this, you will recognize that this is very. Now, ladies and gentlemen, I'm going to give you this basic thing to do in your assignment. Okay? What I want to do is to find out the difference between these 3 things. 1, find out the difference between the coefficient of variation. Please note that down. Find the difference between the coefficient of variation, the skewness, and the kurtosis. The coefficient of variation, the skewness, as well as the kurtosis. So take note of that. Take note of that, because this might be what you've been looking for. All right. So that's it. That's it for now. Get to know this. Even though I've given them to you, I want you to go and find out the clear relationship between them. Now, there's another one that I think you should work it out. Okay? I'll bring the solutions later, but you should work it out on your own. This is the second one. You see, the first one was for 11 months of the year. This one, apart from the data, 200 has been added. So you're going to calculate the same thing, but 200 has been added for 12 months of the year. Okay? So try your hands on this and ensure that you are comfortable with calculating these things. Because sometimes when you use a calculator to do it, it helps you to know that, oh, I couldn't do it. Sometimes it looks like it's easy, I can do it, but when you start doing it, you come to realize that it's not possible to easily do it the way you would have loved to do it. So go through it. Let me know what is working for you. Let me know what is not working for you. And then we'll crack it up together. Next time, we are going to look at grouped data. Okay, we're going to look at group data, and then we'll dig more into this.